Hello everybody, I'm Rafał Szarecki, I'm Solution Architect at Juniper Networks, and I'm going to present the second episode of the SRING in Junos, The Surprise. So, in the first episode, I show how successfully and easily the SRING could be configured, and then the SRING provides the transport for L3 VPN service. However, in reality, not always everything works day one. Human make errors by configuration in software, or even we may have bad luck, like a hardware issue. So in episode 2, we'll look closer to one of such situations. We start with looking at the VPN table at our R1 router. And here we see that some remote prefixes exist. Therefore, we can try to check the connectivity. First, with the loopback of the VRF on the router 2, and we will source it from the local loopback, in VRF loopback. Everything is green, works, pink works, good. So let's try the second one. Oops, traffic is not flowing. Why? What could happen? Interestingly, the destination prefix is active in the routing table, and we get it from router 7. That's because we have IGP full mesh. And router 7 loopback is reachable through the ISIS. The routes are in INET 0, regular IP, as well as in labeled IP table, INET 3, and there is a label allocated to this route. When we trace route toward R7, trace route comes back with 3 hops, so we can easily find that traffic is going through R4, through the north part of our topology. So let's see what happens, where we're losing the traffic and what's wrong. The next hop toward the destination is R3, so we change context to this, terminal to this, and we see if the label seen by R1, how it's handled here. Surprisingly, the label is not in the label table, in labeled routing table. There are other labels, but not 80,007. However, the routing to R7 exists only in INET 0, and obviously there is no label associated with this. In a labeled routing table, INET 3, we have other routers, first, second, fifth, and sixth, but not seventh. There is also missing router 4. This could be a surprise for somebody who is familiar with Junos. In other label binding or label carrying protocols, BGPLU, LDP, RSVP, Junos by default ensures that the LSP is continuous. That is built from the egress to ingress in the order. With the SRING is different. In SRING, we may experience a situation when the LSP is halfway, then there it breaks. A couple of hops are not MPLS enabled. There is no MPLS states, and then another state, another LSP starts again toward the same destination. This creates this strange situation where our service routes, VPN routes, are resolved, but the traffic is missing in the middle. We switch the terminal to router 4, and let's see the routing toward our destination, router 7, at router 4. It should be directly connected, and it is. It's known from ISIS as expected, but there is no label. And the MPLS routing table is empty. We have just a well-known predefined predefined labels here. So the MPLS signaling or Spring signaling doesn't really work on router 4. It would be interesting to see what's going on in the link state database of ASIS, because this is the way how the label information is carried. Labeled database, link state database is same on all nodes, so we'll use R1 to see it. And as you can see in the link state PDUs of R1 or R3, we can see the index number and the sRGB label block. However, for R4, this piece of information is missing. R4 do not advertise his own node seed and do not advertise block. So we come back to switch back to the R4 and see the configuration file. Now everything is clear. Spring is not enabled on R4. So we do so. Okay, now we have the node seed in the link state database, and our end-to-end ping in VPN works properly between R1 VRF and VRF at R7. So, to conclude, R3 is advertising the label block to R1, so R1 can find the label for R7. And even if there is a Spring capable path, the south path, it's not chosen because of the shortest path first algorithm. Unfortunately, router R4 that sits on the shortest path is not configured for the Spring. In result, Spring LSP is half-made, which leads to discards of traffic in the middle of the path. The takeaway of the episode 2 is that Spring allows for creation non-continuous LSP, what in turn could be surprise for somebody used to the classic MPLS signaling, and make troubleshooting a bit harder. Thank you for your time, for your attention, and please tune for the episode 3, which will come soon.